made your way to the correct room. So similarly to the previous session, we will have presenters from several companies today. We have a number of presenters in this session, several companies, and again we will have some time for the presentation itself and then a short Q&A session. And without further ado, it's again about satellite data solutions and satellite data providers. So here we are in satellite data providers, and I would like to give the floor already to our first speaker, so Fabrizio Novali from CETAL. Fabrizio, are you with us?
Yep. You should be able to see me as well.
Yes, and we can see you, hear you. So Fabrizio from the company CETAL.
Yep.
The floor is yours.
Am I going to change the slide, or shall I ask someone for the support in changing slides? Okay, no, I guess I will have to ask.
Normally on the left side, if you click a bit, you should see that that you have the number. You can go up and down or not. It's like a mouse, but you have to ask to control. You see it?
Yeah, ask control, request. And now I'm waiting for the presenter's approval. Okay, control. Wow. Let's see. Now,
yes.
How should I control the slide?
There's a number 1, and then you go down.
Page up and down, they work. Okay, page up and down work. Okay. So sorry, everybody, for this technical interaction. Good afternoon, everybody. My name is Fabrizio Novali. I'm the Earth observation responsible in CETAL. And first of all, let me thank the organizer for this opportunity to present Platino platform and how Platino platform could fit into the framework of the Copernicus contributing mission. But first of all, of course, the question is, what is actually Platino? And okay, sorry, a little bit too fast. All right, not really responsive. Okay, so Platino basically is a multi-purpose small satellite platform in the 200-kilogram class. Platino is owned by the Italian Space Agency and currently is under development by a consortium including 4 of the main Italian space industry, namely CETAL, the company I work for, Thales Alenia Space Italy, Leonardo, and Airbus Italy. Actually, Platino includes some state-of-the-art technology, and this makes Platino a pretty innovative platform. Among all the others, we have an all-electric propulsion that allows to obtain a very high orbit stability, mini control moment gyro for attitude stability, but I think that one of the main characteristics of Platino is its modularity and its compact structure. And these make Platino a multi-purpose platform, meaning that you can basically keep kind of 80% of the structure of the platform itself, and you can basically just adapt for the 20% to the specific payload you want to mount on board. Given the fact that it's capable to hold up to 100 kilogram payload mass, and it can allow for around 200 watt power with a peak of 1 kilowatt, this makes pretty flexible. And in fact, Platino has been already adapted to serve the first 2 already founded by the Italian Space Agency missions, namely Platino 1 and Platino 2. Platino 1 is a SAR mission that is expected to be launched in the end of 2022, and immediately followed 1 year later by Platino 2, that is a thermal infrared mission. Platino 3 and Platino 4 are planned but not funded yet, so not guaranteed that they will be launched, but in case they would be a Veneer, high-res Veneer for Platino 3 and hyperspectral mission for Platino 4. So in the next slide, I'm going to give you some details on the Platino 1 and Platino 2 mission. So Platino 1, as I mentioned, Platino 1 is a SAR mission. Basically, it includes a miniaturized version of the Cosmos Skymet second generation SAR instrument. So it is going to be an X-band SAR working in VV polarization with a left and right looking mode. Actually, we will see in the next slide that the mission is divided into two phases. Before coming into that, we can say that Platino is able to work in mainly two operational modes. The first one is in receive mode, so to work jointly with Cosmos Skymet or Cosmos Skymet second generation, or in case other future Platino SAR. Remember, Platino is a platform, so we can foresee, hopefully in the future, to have more Platino flying, even maybe in constellation. The main acquisition mode for one of the phases we will see is a monostatic imaging in strip map. But we have also a spotlight experimental mode, at least experimental in the first phase of the mission, that will bring the resolution down to 1 meter. Just to give some facts for Platino 1 SAR, we have during the first phase an orbital altitude of around 600 kilometers, the same as Cosmos Skymet, with a swath of 40 kilometers. And in this case, the resolution is roughly 3 by 3 meters, with a looking angle that goes from 20 to 40 degrees. For the strip map, say monostatic acquisition mode, we will be lowering the orbit and the swath will be decreased to 15 kilometers, still maintaining the same resolution. I mentioned that the Platino life cycle foresee two different say phases. Okay, well, let me first say that Platino is going to be launched on a standard sun-synchronous orbit, and the repeat cycle is going to be around 16 days. 16 days is exactly the revisit time of Cosmos Skymet. And in fact, during phase 1, whose duration is foreseen to be 1 year, the nominal working mode for Platino will be in B-static mode with Cosmos Skymet. So basically, it's likely the orbit configuration is not fully defined yet, but it's likely to follow Cosmo or Cosmos second generation and to receive the echo backscatter from the pulse emitted from Cosmos Skymet. During this phase, we will see a significant duty cycle of the 50% in receive mode only that go decreased to 3% when working in monostatic mode. Monostatic acquisition are not excluded during the first phase of the mission, but they will be opportunistic acquisition. So mainly the focus will be on B-static acquisition. Then there will be a deorbiting phase of around 6 months, and in the second phase, Platino will fly in a lower orbit, around 400 kilometers, and then we will have a switch between the acquisition modes. So in this case, the nominal official acquisition mode will be strip map, but we can't exclude that some opportunistic B-static acquisition will still be available, even if, again, the main acquisition mode will be strip map. In this case, the duty cycle is more or less the same, apart from a slight reduction in the duty cycle for the monostatic acquisition mode. Now, for what concerns Platino 2, that again is a little bit, behind Platino 1. While Platino 1 is already under construction, Platino 2 is still under construction, but in the very initial phase, still some things to be fully defined. But this is going to be a thermal infrared mission. Medium resolution, I would define a thermal infrared mission because we will have a resolution that goes in the order of 40 to 60 meters. There will be 4 bands in the thermal infrared band. You see the numbers here with a resolution of 1 micron. And the revisit cycle in nadir will be 52 days. While if you change and say consider the field of regard, we will be able, as you can see in the graph on the right-hand side, to achieve a revisit in the same area, of course, with different angle, down to 7 days. Okay, so there's something that is not mentioned here, but probably is worth to be mentioned, is that Platino 2, the thermal infrared mission, is likely going to host also a veneer camera. The resolution of this veneer camera is going to be 5 by 5 meters, and the main purpose as a secondary payload will be to allow co-registration and cloud masking for the thermal infrared that is going to be the primary, acquisitions. But at the same time, we can't exclude that some of these images will be also used for Earth observation. So it's going to have 2 payloads likely on the same platform. A very quick, and then I will leave the show to other speakers, overview on how, well, if I can change the slide, yeah. how these two missions can fit into the Copernicus contributing mission. Well, this is the picture that what this table was taken from the RFI that is issued related to the Copernicus needs. And you can see that Platinum 1, the SAR mission, falls in the range of the very high resolution SAR mission, providing a resolution of around 3 meters in the monostatic acquisition mode, but also provide a kind of experimental, not experimental, I would say scientific interesting bistatic acquisition mode. In terms of responsiveness, we can guarantee, at least in the initial phase, let's say from ordering acquisition to delivering, something in the order of less than 12 hours. But of course, this is going to be improved with the mission that will enter the operational phase. Slightly different from what concerns the thermal infrared. So Platinum 2 is going to be a little bit different than what's currently available, because we have many high-resolution missions in the Venera, not so many thermal infrared missions, at least in, say, medium resolutions with around 50 meters of resolution. So, and basically, no one with these 4 bands. So I think this is going to be pretty useful to understand also what new, say, opportunities, I think, for example, to the application to agriculture, will be opened by the thermal infrared on board of Platinum 2. And let's say that Platinum 2 can support and can also pave the way for the future candidate LSTM, the Land Surface Temperature Monitoring Sentinel-8 mission. So we believe that this can be something interesting for the overall Copernicus community. Okay, that's all I have. I hope to be on time. If you have any question, I will be pleased to answer.
Thanks a lot, Fabrizio, for your presentation. So to those of you who are just joining, I'm Jean-Christophe Gros. We are in the Satellite Data Providers session. There are various presenters, one after the other, and you can submit your questions to be answered. So in the present case, I don't see any question in the Slido. Can you confirm, Katarina?
Yeah, not for now. But participants can submit their questions. Mr. Novali, thank you very much. Just one question: did you see a timer appearing, or you?
No.
It was okay. No, okay.
No timer here.
So then we have to keep track of the time.
Yeah.
But thank you very much. Very interesting, and the fact that you use the table of the RFI is excellent. It gives us a good idea indeed. Yeah, thank you very much.
And I think you gave a very clear presentation of what we would get with Platinum 1 and 2 in particular. So thank you for that. And with this, I would like to move to the next speaker, Stefan Levens from Vito.
Hi, good afternoon. I hope you can all hear me well.
Yes, I can hear you very clearly.
Okay, so I'm Stefan Levens, and I work at Vito Remote Sensing. Vito is a research institute in Belgium, where we have quite a sizable department of about 100 people working in remote sensing, but that is, of course, going for the full chain from really designing instruments up to doing lots of application work. So, and I'd like to talk to you today about a project we started, and we named it Calibreo, because it's an in-flight calibration service we intend to offer, and it's specifically targeted towards small satellites. And therefore, I think it's interesting to show it in this session. So, should I go to the next slide? Oh, I can ask control. Oh, it's already there. That's even better. So, when talking about the calibration of small sats, well, you could think calibration has been done before. It is very well known with the main missions, and we have excellent calibrations for the Sentinels, so it's not that new. But actually, if you think of it a bit more, if you're looking into new space, into smaller satellites, it's actually much more difficult, because you have a smaller platform, so you have larger deviations, more thermal problems. All that is quite a lot more difficult. Typically, you don't have any onboard calibration devices to do things on your radiometry, and also you typically have more downlink limitations. And when we're talking about in-flight calibration, looking at targeting specific areas just to do your calibration, this can be a real big problem if you can't do many specific downlinks. Then of course it's hard to reach a good accuracy. Now it's more difficult, and also typically many small sat missions are less equipped, because when we talk to a lot of different people at different companies, we feel that they often underestimate the complexity of in-orbit calibration. It's really a specific field, and well, you can't be expert in all fields, I think. So there's sometimes limited expertise in calibration validation, which is, well, something that you build up over the years, and you can't just take it out of the blue, use the book and just do what's needed. It takes a lot of time. Also,
Stefan, I'm sorry to interrupt. There is a comment in the chat asking you whether you can speak up, because not everyone apparently can hear you well.
Okay, I can try to speak a little bit louder. Is this better?
Yes,
okay.
That's much better.
Okay, I'll do just that. Okay, I was explaining that indeed the complexity is sometimes underestimated, and then of course many of these smaller missions also have much smaller budgets to spend, and they can't spend their money twice. So often what they spend on calibration is a lot less because they have different technological priorities. They sometimes, they want to do something new, do groundbreaking things, but then there's also other areas we need to be covered well. And then the last challenge is that often there's also higher expectations. With shorter mission lifetimes, you don't want to spend 6 months doing commissioning, because then in a 1-year mission, your mission is half over yet. So they want fast results. So all that makes it harder to have a really good quality in have a really good quality in doing these small set missions and having a really very accurate calibration, both in the radiometry and in the geometry. So that's why we think it makes sense to offer calibration as a service. And so not doing every company doing it themselves, but a company like us, because we believe we have something to offer in that field, and offer it to other companies. So you can go to the next slide, please. Okay, so because, like I just said, we have a long-standing expertise in doing both radiometry and geometric calibration, and a lot of that has been built. We built our team doing calibration when we were heading the Probe IV mission, where we built a full calibration system from ground up. We took in many complementary methods and built up through the years a lot of operational expertise. But it's not just that. Our experts have been involved in CEOs, the calibration work groups. There's contributions to other missions, also in small sat, like we did the calibration, both the radiometry and geometry for Hyperscout, and numerous missions over a period of 10-15 years. On the other hand, we also do some of the instrument and system development, so we have an idea of what is going on there. We work with a lot of we worked on frame-based hyperspectral images, and we have done a lot on application noise. So one of the aspects where we are really focusing is lunar calibration. There's not a lot of people doing that, but that's one thing that we are doing. So you can go to the next slide. So here's what we will offer as a service. I won't go into the details because we're running a little bit out of time, but we're looking at different levels, just a simple level where we verify the calibration that the company does themselves, an express calibration where we really focus on getting accurate results in as short time as possible, and then of course a premium calibration where we go for the ultimate accuracy. So you can go to the next slide. So how do we see all of this contributing to Copernicus? Well, it's in two ways. I can say it in two words. It's about efficiency, to shorten the mission development time, because you don't have to develop your own calibration expertise. You reduce the risk of having not the best image quality, and you shorten the time you spend in commissioning during the mission, so you have a well-calibrated state much faster. Now I go to my last slide. The other part where it can contribute is indeed in increasing the quality of the mission. So you can do this as an independent validation. We have a lot of complementary state-of-the-art methods, so we can go for the highest accuracy possible, specific solutions that target typical small set problems, and we can also offer cross-calibration between different missions. So that's about all I wanted to say. Thank you for your attention.
Thank you very much, Stefan. I don't see any question in the Slido for the time being.
It's not a problem, Jean-Christophe, because actually we're having all the presentations first and then the questions at the end of the session.
So let's proceed then to the next presenter. There will be time in any case afterwards for questions, but we could have taken one there.
Thank you.
We are not running out of time.
Yeah,
So the next presenter is from Airbus. Patrick, are you with us?
I'm here. Good afternoon, everyone. Can you hear me?
Yes, very well. We can see you as well. So Patrick, the floor is yours.
Thank you. Thank you very much. I'm just asked to control. Yes.
Actually, for setting up reason, it will be easier if you can just say next slide and we'll change the slide.
Okay, can you just go back to the first slide? Yes, I will ask you then. Thank you very much. Can we go back? That's the second slide, actually. Okay, perfect. Thank you very much. So yes, my name is Patrick Jeskler. I'm a sales and business development manager for Geospatial Services with Airbus Defence and Space Intelligence. And today I have a great pleasure to present you next generation constellation Pleiad Neo, the first European 30 centimeters optical satellite constellation. And we can move to the next slide. So here, let me tell you about Airbus's next space strategy supporting EU and the Copernicus contributing missions. And here we are focusing on innovation, digitalization, and the technical progress that we see is fundamentally transforming.
So I think we've lost Patrick. I propose to wait a few 30 seconds whether he can rejoin us. Otherwise, we will switch to the next presenter. Just as a warming up for our next presenters will be both Daniel Carrasco and Ciro Farinelli from Hisdesat and Airbus for them to warm up in case Patrick is not rejoining us shortly.
Is there a way to contact him?
I will send him an email and see if we can find a solution for that technical issue.
Yes.
Okay, thank you. Then if you can also tell him that in the meantime we are switching to the next presentation, and then we will come back to him.
It's maybe because he was trying this. I don't know. Okay, let's have the next presentation. Yes.
Okay, so on as I just mentioned, in fact, we have a joint presentation from Hisdesat and Airbus from Daniel Carrasco and Ciro Farinelli. So if you can hear me, the floor is yours. Whoever wants to start.
Thank you very much. You can connect the slides, please. Hey, good afternoon. My name is Daniel Carrasco. I am from Hisdesat, and we are delivering this presentation together with Mr. Ciro Farinelli from Airbus. We are going to talk about the WorldSAR constellation made of TerraSAR and PASS satellites and its future. Next, please. Okay, the high-end missions are a challenge for any commercial investor. Our respective companies, Hisdesat and Airbus, we are proud to have found either a national anchor customer or a public-private partnership to risk such investments and go ahead with our rather high-end missions. So In this way, we have been able to team up the two satellites from Airbus, TerraSat and MX in information flying, together with ours, PAS, to create their constellation. And this has been possible thanks to our partnerships in the case of Airbus with DLR and in the case of ISTESAT with the Spanish Ministry of Defense. It's very important to remark that the satellites, they have full compatibility, and by putting them together in a constellation, of course, we have doubled the capacity, have backup capacity, strongly improved the reliability, of course, keeping interferometric repeat pass, improved also the accessibility. And it's important to remember that all these capabilities of the constellation, the WorldStar capabilities, are available now. Next, please. So, at present time, we have 3 satellites, TerraSat and MX and PAS, but we have plans for the future. Both companies have engaged in the process of the renovation of the space assets. In the case of ISTESAT, we are telling of PAS-2 satellite, and Airbus is going ahead with a TerraSat X now. The key message that we want to transmit is that we are going to assure the continuity beyond 2035, and not to say an improvement of the performance. Of course, everybody is going ahead with a potential national partnership. And now, we are also trying to see if we can engage with an additional third party to add an additional satellite to the constellation. Next, please. On this, I will go very fast. The message I want to transmit is that we are already delivering imagery to the Copernicus services, and that with the new generation satellite, we expect a quantitative and a qualitative improvement. We expect to address more Copernicus services, and we also expect to improve better what we are already delivering to them. For us, it's important to put in place European assets to contribute to Copernicus and ensure autonomy. And now I will give the floor to my colleague Ciro Farinelli from Airbus, who will continue the presentation.
Thank you, Daniel. So this is Ciro Farinelli, Future Programs Manager for Satellite Business at Airbus Defense Space in Germany. Can you go to the next slide, please? All right, so here is in collaboration with service providers around the globe, and I'm talking about including established players and new space startups. We've been also developing a network of partner antennas in order to provide direct access to the WorldStar constellation. And this network continues to grow. And today, we're granting real-time access for Europe and a range of hotspots around the globe. Next one. Oh yeah, so this is, in addition to the benefits to the Copernicus services, which has been described by Daniel before, I feel like it's worth to mention also the Copernicus digital elevation model evolution provided by the TerraSat X and PanamX missions. So I'm not going to mention the ones which are free and available today, so the 30 meters global and the 10 meters in Europe. But I would like to mention the ones that we are working on, so the COPDAM evolution. And what we are working on is a resolution of the digital elevation models of 1 pixel, 10 meters globally, and 5 meters, 1 pixel for Europe, using our SAR technologies. And then by using the optical sensors, we're going to be capable to deliver a solution of 1 meters for urban hotspots. And this is possible only if the European Commission is going to be supporting us. Next one.
So Ciro, if you can accelerate, because we don't have much time left, 1 minute for to conclude the presentation.
Thanks for the note. Yeah, it's going to be the last one. So
Very good.
we believe that it's worth from our side also to mention like some of the observations that we developed lately. So there are just 4. The first one is a level playing field for all the European space investors. This means that basically all the investors, whether they are corporate, third party, venture capital funded, should be treated on a level of a playing field, which means that each business case needs to be benefit from a European anchor customer that is committing to a certain data uptake. And then the second observation is the European anchor customer. And that's a key one, right? So while a general framework agreement is okay to support a business case, but a committed budget for the lifetime of a commercial mission, or at least like for the duration of the multi-annual financial framework, will really make the difference in terms of the risking of the business case and also enable like further investments. Third point will be the competitive procurement through dedicated service level agreements. So, you know, the European commercial radar missions are pretty much capable to deliver fully coverage of all the European needs. But to ensure such a fitting services for the Copernicus end users, we need to have a set of dedicated service level agreements. And eventually the last one is the level playing field for European market access. So I agree that the European commercial mission preference to achieve autonomy in space is actually a very encouraging step for investors. But at the same time, we need to keep in mind that each space mission needs to rely on a global market access based on fair conditions. And in this sense, trade agreements that provide reciprocal space market access shouldn't be compromised. And I give you as an example the seat agreement between the European Commission and Canada. So final slides. Right, so it was a pleasure being here. Thanks a lot. Sorry for being a little over time, but feel free to reach out also to our business contacts. Thank you.
Okay, thanks a lot, Daniel and Ciro, and also with this double view, both technically and also giving some insight on the way you would see the business in the future, with some considerations also with this reciprocity. We are taking note of that. And with this, I would like to come back to Patrick, if he has been able to rejoin us in the meantime.
Yes, I'm back. Can you hear me?
Yes, we can hear you.
Very good, very good. I don't know where you lost me. Which slide was there?
Can you go back?
Go back. I think maybe because there was a video, and that's.
I think we were on that slide. Yeah.
Yes.
Okay.
Yeah.
Okay. Here, perfect.
Yeah.
So here, so as I said, so I would like to tell you a little bit about the Airbus next space strategy, supporting EU and the Copernicus contributing missions. So here, Airbus is focusing on innovation, digitalization, and the technical progress that is fundamentally transforming all industries, markets, and then is reshaping our consumer demand. So we see that society is increasingly connected, needs more data, more services, more details, and more precision. And here at Airbus, we are dedicated to deliver this data to our customers much faster, provide more revisits more frequently, and supported by automated analysis, artificial intelligence to help extract the valuable information from the millions of square kilometers of data. And of course, make the access to data much easier in a digital fashion through the digital platforms like One Atlas, provide the tasking, and of course, the more confidentiality and security as priority number one to our customers. And the next slide. I'm sure that most of you is familiar with our constellation. So already today we have the first two Pleiad Neo satellites. So it's the 30 centimeters resolution, the first European 30 centimeter constellation. And in addition to that, we have our Pleiad satellites with 50 centimeter resolution, the Spot 6/7 1.5 meter, DMC constellation, and the Vision 1 providing 80 centimeter resolution. And of course, our famous the radar constellation that Ciro just presented. And we have our Hawkeye constellation providing radio frequency And our future as well constellation is the CO3D. So this is the 4 satellites flying in 2 pairs. They're flying in opposition, which gives the ideal concept for the stereo acquisitions. And we have our Zephyr, which is solar-powered UAV, and that will deliver video surveillance over large areas. And of course, the Jerome mentioned, I'm sure, the future TerraSAR X Neo. And we can go to the next slide. Here, oh, I'm going to crash. There's a short video, so I would like to show you as well what comes with the new Pléiades Neo satellites. So some technical information and the Airbus commitment to the Earth observation. So as I mentioned, yes, so first European 30 centimeters optical satellites. So by the 2022, we will have 4 operational satellites in orbit, which was really technical challenge, but our engineers stepped up to the task. And 75% was redesigned from the ground up. And we can go to the next slide. Sorry, I'll be quick. And next one. Yes, and you see, so with the 4 Pléiades satellites NEO, the capacity will be 2 million square kilometers per day, with the geolocation accuracy less than 5 meters, and the lifetime of each satellite will be 10 years plus. And it's important to say that the satellites are commercially available by Airbus, so there is capacity for our consumers and the EU and the contributing missions. And the last thing, the tasking, which is very important, the tasking plan is updated every 25 minutes. So the customers will be able to program satellites 15 minutes before acquisitions. And the last one is just a quick pic of the quality of Pléiades Neo satellites. So the image recently acquired over Tokyo. I'm not sure if you can see on the small screen, but the image is really amazing. And we can't wait to give the access to the satellites to our Copernicus contributing missions. Thank you very much.
Thanks a lot, Patrick, also for resuming the presentation and concluding quickly and providing this landscape. Which brings me now to the last presenter, Helen Goetz from the European Space Imaging. Henning, are you with us?
I am. Good afternoon.
Good afternoon. So the floor is yours.
Yes, thank you. Okay, so I do not, sorry, I do not have control of the presentation, so you will click through it?
Yes.
Okay, fine. Yeah, so thank you again for the opportunity to present here. It was an interesting event. My name is Helen Goetz. I work for European Space Imaging, and as such, I'm the project manager for all our Copernicus and CCM related activities. The next slide, please. You might need to click through it a bit. Sorry. Correct. Yeah, our company is not really a new space actor. We are already a, let's say, established company and have already been contributing to the Copernicus program for quite some time. Just very briefly on this, we were founded in 2002. A major milestone was that we have formed the so-called Worldview Global Alliance with our close partner Maxa. Most of you probably know this company. They are the owner and operator of the Worldview constellation. We come into play here because we run a ground station together and at the German Aerospace Center near Munich in Germany. And with this ground station, we have the capability to steer the Worldview constellation as it flies over Europe. So we do direct tasking of the constellation, which allows us to still squeeze in last-minute orders because we finalize the collection plan very shortly before the constellation flies over Europe. We can also directly downlink the imagery once it's collected, and because of that, we can deliver very fast the imagery to customers. So over the almost 20 years, we have, I would say, developed into the leading, or at least one of the leading providers of 50 centimeter optical VHR imagery to customers in Europe. We already have significant supply contracts with European institutions. I just mentioned a couple of them here. ESA, JRC for the CAP monitoring, then also EMSA for maritime surveillance, and also in the DNI and security service fields, the EU SATSIN and also Frontex. Next slide, please. Yes, thank you. Also here, just very briefly, the timeline of the satellites that we have been steering over the past years and are still steering. I just highlighted the ones which are still active in yellow. It's 4 satellites currently, Worldview 1, 2, 3, and GeoEye-1. Just some major features. The satellites are not identical, but they vary in terms of resolution from 30 centimeters to 50 centimeters pan resolution. And the bands on board vary also between just panchromatic and an 8-band multispectral instrument. But what I would say is more of interest today is what is coming next year. This is written in orange on the right side of the image is the Worldview extension and replenishment constellation from AXA, the so-called Worldview Legions. I provided some more details on these on some later slides, so I think we can go to the next one. Right. This is just a recap of our contribution to the, back then it was still called GMES program, but nowadays it's called, of course, called Copernicus program. So we have been contributing to the program since 2011, so almost 10 years, I would say. And also here we have developed into one of the major providers of optical VHI imagery to the Copernicus services, notably the security service, but also emergency management and the land monitoring services. Some of the key offers and achievements over the past 10 years. So of course, in general, we offer worldwide tasking. Anything that exceeds our ground station communication cone is executed by our partner Maxa. We also run a 24/7 emergency ordering desk because, as you know, a couple of the Copernicus services need imagery anytime. So that's usually the Copernicus emergency management service, but also the security service. And what we also offer is, in general, fast response times and order turnaround times. So globally, together with Maxa, we accept orders for new tasking until 6 hours before the pass. And over the past years, on average, we have been delivering from sensing or archive order placement within 1.5 hours. Something which should also be mentioned, I think, maybe this will also be discussed tomorrow when it comes to an outlook to the entire CCM activity. There's also a central infrastructure in place. And yeah, over the past years, we have developed a dedicated ordering and delivery interface to the Copernicus security, to the Copernicus so-called data warehouse. And this is also something that, yeah, we are continually upgrading. Next slide, please. Yes, I think we can just very briefly here also again, over the past years, we have contributed to the so-called systematic or core data sets. In 2012, the so-called Urban Atlas, with 8-band imagery over more than 300 urban zones and urban areas in Europe. 2015, we had provided roughly 1.3 million square kilometers for the VHR Image 2015 coverage project. And this year, I cannot tell too much about this yet because it's still ongoing. We are also contributing to the VHR Image 2021 coverage project. So the collection season for that is already over. But the activity of composing the coverage from the various data providers is currently ongoing. Next slide, please. Yes, and besides the systematic data sets or core data sets, there are also the on-demand orders. For VHR data, these come mostly in the so-called rush mode or emergency mode. Just some statistics here. So on average, we receive more than 700 of these per year for archive data or tasking. And also here, we distribute roughly 120,000 square kilometers of VHR data to the Copernicus services for these on-demand orders. Most of these orders are located inside our ground station communication cone. It's roughly 70%. And again, here, what is key here and what we can also deliver is fast order turnaround times of delivery in, as I said, roughly 1.5 hours on average. Okay, so
Thank you, Edith. Yeah.
then the
Are you
outlook.
finished? Yeah.
Yes, next slide, please. I think this is exactly of most interest to you when it comes to the future of the CCM activity and what we can contribute to it. This is some details on the upcoming Worldview extension constellation, the so-called Legions. It's going to be 6 satellites. When it comes to the payload and the instrument, they will be identical with an 8-band multispectral instrument and a GSD in the panchromatic band at nadir of 29 centimeters. First launch, it has already been delayed, unfortunately, a bit. It was planned for this year already, the first launch, but it will be delayed into the next year. But what is striking here, I would say, is that 4 of the satellites will not fly in synchronous orbits, but in mid-inclined orbits. And this will open up new use cases. There will be up to 15 daily revisits over mid-latitude areas. So it will be possible to have not just 1 image per day, but actually to have monitoring of the same target throughout the day, from morning to the afternoon. This is probably something that we believe will be very relevant and also beneficial to the Copernicus Security Service and also the Emergency Management Service.
Okay.
My next slide, please. And this is also.
If you can conclude.
Yes, it's the last one. I mentioned this dedicated interface. This is also something we are upgrading in the background. It opens up new ordering mechanisms for the Copernicus services, but also new data access mechanisms. Plus, from next year on, there will also be a new delivery timeliness category, and we are opening up 30 minutes delivery to the Copernicus services.
Okay, thanks a lot for your presentation.
Yes, you're welcome.
Quite a landscape as well of capabilities.
And just some examples.
This concludes the various presentations, and now we have some time for a few questions. So please feel free to submit questions that we are about to take. I think I see one question for you, actually. So it's to Henning. Why were the SWIR bands omitted in the Worldview Legion missions compared to Worldview 3?
Yeah, that's a good point. I believe this was a business decision from AXA, who are building the satellites and also operating them. As you know, I mean, there was also one SWIR instrument on board of Worldview 3. I assume it was a trade-off between cost and also benefit. Obviously, I suppose the demand for the SWIR instrument has not been too high. At least there will be 8 bands available on the Legion satellites.
Okay, so it's not in principle, it's not technically related, but more a question of market, if I understand correctly your answer.
I do not have let's say a formal comment on this from AXA on that decision, but I assume this is one of the reasons. Yes.
Okay, thank you very much, Henning. Is there any question that you see, Katarina?
No, not for now. I myself have a question for the speaker from Vito, actually. To further understand this very interesting calibration exercise. Just to understand, because we have noticed in some other presentations that there are activities being set up by SMEs to become a companion to our Sentinels. Sentinel-2, for example, and they say, yeah, the Sentinel-2, for example, that's our calibration instrument. If you want, we calibrate our satellites based on Sentinel-2. Can you give some feedback, or what is your take on that in relationship with your project? Thank you.
Oh, okay. Yes. It's a very good question. Indeed, many of the small missions do efforts to be in line with Sentinel-2 because that is known to be very well, very accurately calibrated. So it is a very good idea if you have a small mission that you want to calibrate it to Sentinel-2. But actually, the best approach is to first calibrate your instrument to the extent possible on its own, and then do that cross calibration, because your instrument will never have the exact same spectral responses and so on, and it has very different characteristics. So if you just only rely on trying to force it into being Sentinel-2-like, you cannot reach equality that if you first have your instrument as good as possible and then do this cross calibration. So it's a bit of a subtle technical thing that they are complementary. Definitely, it's good if you have some products that you want to merge or use together with Sentinel-2. Please do this cross calibration as well as possible, but don't say, okay, my calibration as such for my own instrument is not important anymore because we're going to cross calibrate anyway. That will generate lower quality results, I think.
Okay. It's just because sometimes the argument is used for cost efficiency.
Yes. I can perfectly understand that, because having all these specialized tools and then specialized methods for doing the calibration on your own, it costs a lot. So that's exactly why we are proposing this model where we could do this a lot less expensive by using our standardized expertise and doing the same kind of calibrations for different missions. And then it's not a burden anymore to do this two-step process, to do your own calibration first and cross-calibrate in the next phase.
Okay, so you're saying, so your project is actually saying, leave it up to us. You don't even need to do their own calibration. We will take that as a service. You provide it as a service.
Yes, that's the whole
calibration.
idea.
No, calibration as a service. CAAS. Yeah.
Yeah, indeed.
Okay. Thank you very much. Yeah. Any other questions? How about the timing? Where are we?
I think we should be about to conclude, because then we will go back to the main room, and in 5 minutes we should go to the concluding remarks. So it will also be the opportunity for a few of you to have a short break of 1 to 2 minutes. So with this, unless there is a last-minute question, but I don't see any, I would like to thank all the presenters for this very